Good morning, dear students. My name is Ferhan Mazher, and today is 31st of the March and 2021. And right now, I am with the O3 class. And today, we have set our hearts to solve May June 2012 Physics 505421 paper. In this session, we are going to solve the section B of this paper. We call this paper paper 2. And let's start today's paper. So we are solving May June 2012 and we will be solving section B. So let me go to the section B. Okay, so here we go. So section B is showing on your screen. Question is figure 9.1 shows a room heater. Figure 9.1b is a diagram of the electric circuit of the heater. The fuse has not been drawn on the circuit diagram in the figure 9.1b. On the figure 9.1b, draw the symbol for a fuse in the correct position. You see, the fuse is always connected in the live wire. Okay, so we will connect the fuse in the live wire. I have done this in on my paper. Let me show you my work. And here we go. So on your screen you can see that I have shown here a live wire, and in the live wire I have shown a fuse, and this is the electric symbol for the fuse. So kindly draw this shape on your booklet. Are you done? Okay, so let's move to the next part, and the next part is state the part of the room heater to which the earth wire is connected. See, the earth wire is always connected with the body of the equipment or the body of the machine. Here, the machine with which we have to connect the earth wire is the electric heater. So we will connect the earth wire with the metal casing of the heater. I have written this answer also. Let me show you my answer. So here we go. Earth wire is connected to the metal casing of the heater. Kindly write this answer in your booklet. Are you done?
Done, sir. Yes, sir.
Okay, so let's move to the next part. The next part is the earth wire reduces the chances of an electric shock if a fault develops in the room heater. State one fault that causes an electric shock when a person uses the room heater without an earth connection. You see, if by chance the insulation on the live wire gets damaged, the live wire comes in contact with the casing of the heater, then the casing of the heater will also become live. So if by chance somebody touched it, he will be electrocuted. He will get electric shock. I've written this answer. Let me show you my answer. So on your screen, metal casing of heater comes in direct contact of the live wire. You can also write few more lines that the metal casing of the heater comes in direct contact of the live wire. The metal casing will also become live. So if somebody touch it, he will be electrocuted. When you are done with your answer, kindly let me know. Are you done?
Done, sir.
Okay.
Yes, sir.
So let me check the marking scheme also. We are on question number 9. You see, the marking scheme is also now showing on your screen. The fuse symbol correct in the live wire before junction of the two elements. We are done with this. The metal case outside means that was the second part. Live wire touches the case. Live touches person. And okay, so this is what we have to write. Okay, now is second part. Question number question 9 part A part 3. It's second portion. Explain how using an earth connection prevents an electric shock. You see, what happens the when you connect the earth wire and the casing also becomes live. So through the earth wire, the current will go to the ground. The current will go to the ground through the earth wire. The resistance of the earth wire is less than the resistance of the human body. So the most of the current will go through the earth wire instead of going through the person who touches the heater. Another very important thing is when the current is going to the heater plus the current through the earth wire is going to the ground, the amount of current which is coming from the main supply, that will increase. So when the supply of the current will increase, the fuse which you have connected in the live wire, it will blow, it will melt, it will blow. And when it will blow, it will cut off the supply of the live current to the heater, and the heater will be isolated from the live current. So the heater will become safe and the people will also become safe. So I have written this answer also. It's a 2-mark question. Let me show you my answer and then we will see. You see, let me read my answer. Live current will go to the ground through earth wire instead of going through the person who touched the metal casing. Current going to earth will increase the supply of current from main supply and it will blow the fuse. Heater will be cut off from the live current. So this is my answer, and let me check the marking scheme and then you can write. Or if you like to write this answer, kindly write it, but be quick. Live current will go to the ground through earth wire instead of going through the person who touched the metal casing. Current going to earth will increase the supply of current from main supply and it will blow the fuse. Heater will be cut off from live current. When you are done with this, kindly let me know.
Done, sir.
Okay, very good. Let me check the marking scheme. Let's check the marking scheme. What the marking scheme says. Current goes to earth. Current does not go through the person. Fuse blows. It's a 2-mark question. And I think we have written all the aspects of this answer. We will get full marks. Do you understand, Muskan?
Yes, sir.
Okay. So B first part, it says this type of room heater is very efficient. Explain what this means. When I say that a machine is very efficient or a heater is very efficient, it means that most of its input energy is converted into useful output energy. A very small amount of input energy is wasted. Only a small amount of energy is wasted. Most of the energy is useful output here. So the efficiency means this. And let me show you my answer. I have written this answer also. So on your screen, my answer is showing most of the input energy is converted into useful output energy. very little amount of energy is wasted. Most of the input energy is converted into useful output energy. Very little amount of energy is wasted. That is the meaning of the efficient heater. Kindly write this answer. When you are done, kindly let me know. Most of
Done,
the
sir.
energy output is useful. The useful here is heat. Little energy is wasted. That's the marking scheme is saying. Are you done?
Yes, sir.
Okay. So let's move to the next part. He says the room heater is a convector heater. Describe and explain how thermal energy passes around a room by convection. A very, very famous question. You see, the air which will be near the heater, it will absorb the thermal energy. The molecules of the air, they will move away from each other. The air, this hot air will become less dense. This less dense air will rise upward. From the top, cold and dense air will sink. This will set convection currents in the room. And by the help of those convection currents, the heat will be distributed throughout the room. It's a 3-mark question. I have written this answer also. Let me show you my answer and then we will see. Air near heater becomes hot. Its molecules move away from each other. Air becomes less dense. Less dense air rises upward. Cold and dense air sinks. This set up convection currents. Through convection currents, heat is distributed throughout the room. Kindly write this answer and be quick. When you are done, kindly let me know. Hurry up, girl. Are you done?
Yes, sir.
Okay, good. So let's check the marking scheme. What the marking scheme says? The marking scheme says hot air rises, not heat rises. Say hot air rises. Density of the hot air is lower. Convection current mentioned. Hot air rises and the cold air falls. So I think we have covered all the 3 main points which we want in the answer. Do you understand this?
Yes, sir.
Okay. Okay, so we are moving to the next part. He says figure 9.2 shows the power output of the room heater when each switch is closed. Determine the power output of the room heater when only the switch B is closed. You see, the total power is 2100 watt, and when only one switch is on, the power is 600 watt. So when the switch B only closed, that power will be 2100 minus 600. I've done this on a paper. So on the screen, you can see the first part, 2100 minus 600. That will be 1500 watt. So let's check the marking scheme. What the marking scheme says. Yeah, marking scheme says 1500 watt. Okay. The room heater is used with both switches closed for 2.5 hours. So the power used will be 2100 and the time is 2.5 hours. It says calculate the energy output of the room heater in kilowatt hour. The formula for the energy is power multiplied time. The power should be in kilowatts and the time should be in hours. The power is 2100 watt. So if you want to convert it into kilowatts, you divide it with 1000. So what I will do, I will divide 2100 with 1000 and it will be converted into kilowatts and then we will multiply it with the time. The time is 2.5 hours. I've done this on a paper. Let me show you my work. Oops, it was done on the previous. Yeah. So you can see 9C second part. Energy is equals to power in the kilowatts multiply time in hours. The power is 2100 watts, so I will divide it with 1000 to convert it into kilowatts, multiply 2.5, and the final answer will be 5.25 kilowatt hour. Muskan, do you understand this?
Yes, sir.
Okay, let's check the marking scheme. The marking scheme says 5.25 kilowatt hour is the right answer. You can see here. Okay, so we are done with this part. Let's move to the next part. He says calculate the energy output of the room heater in the joules. The power, the formula is again same. Energy is equals to power multiplied time, but there is one difference. Now I want the answer of energy in joules. If you want the answer in joules, the power should be taken in watts and the time should be taken in seconds. 2 hours, how you convert 2.5 hours into seconds? You multiply it with 3600. Why multiply with 3600? Because in 1 hour there are 3600 seconds. Let me show you my work. I've done this on a paper. So now on your screen that thing is showing. So the question number 9C, second part, energy is equals to power multiplied time, but this time the power will be taken in watts, the time will be taken in seconds. So 2100 watt multiplied 2.5 multiplied 3600 and the final answer will be 1.89 expo 7 joules.
Done, sir.
You're done.
Yes, sir.
Okay. So let's check the marking scheme. What the marking schemes 1.89 expo 7 joules is the right answer. The marking scheme is showing on your screen. Okay, so we are moving to the next question today, my dear students. We are doing May June 2012 2-1 paper, and we are attempting a section B. We are done with the question number 9, and now we are starting question number 10. In this session, we will only doing it section B. Figure 10.1 shows the path of a ray blue light as it passes through a glass prism. State the wave term used to describe what happens to the ray at the light at the point A. You see, this is a prism. It's a transparent material. And at the point B, the light was traveling in the dense medium in the prism. And instead of going out, it was reflected back into the glass at the point B. Why this is happening and what we call this? You see, the why is not the question here, but he says what happened here. The sorry. I just he is asking for the point A. Okay, sorry. At point A, what is happening? At point A, the light is traveling in the air and it entered into the glass. And you can see the light was traveling in the air and it entered into the glass and the path of the light has changed. So this is refraction. So what happened? Only you have to state the name. The refraction of the light has taken place. Muskan, do you understand?
Yes, sir.
Okay. So the refraction of the light has taken place. I have written this answer also. Refraction of the light took place at the point A. Refraction of the light took place at the point A. This is what you will write in your answer. Okay. Now, next part. He says calculate using the angles from the figure 10.1, calculate the refractive index of the glass. So so you see here, the angle of incidence is 45 in the air, and in the prism, the angle of refraction is 29. Angle of incidence in the air is 45, and angle of refraction inside the glass is 29. The formula for the refractive index is very simple. N is equals to sine I divided by sine R. N equals to sine I divided by sine R. Sine 45 divided by sine 29. N is equals to sine 45 divided by sine 29. I've done this on a paper. Let me show you my work. And let me increase the size. Okay, so question number 10a, second part. N equals to sine I by sine R. Remember, the angle which is formed in the rare medium is always put in the numerator in this formula. So we will have sine 45 divided by sine 29. So N is equals to 1.46. When you will do this calculation in your calculator, the answer will be 1.46. Muskan, do you understand this?
Yes, sir.
Okay. So let's check the marking scheme if our answers are right. So here we go. A refraction, and here the final answer for the second part will be 1.458, approximately 1.46. So our answer is right. Okay, explain why the ray does not emerge from the prism at the point B. Okay, this is that famous thing which I was trying to explain you earlier. Oops. His question is explain why the ray does not emerge from the prism. Here, the prism is transparent. When the light strikes this face at the point B, the light do not go out of the prism, but it is reflected from this transparent boundary. His question is why. Explain this. You see, the light is traveling in the dense medium. And at the point B, the angle of incidence is greater than the critical angle. That's why the process of total internal reflection has taken place. And the light has reflected from the boundary of the dense medium and the rare medium back into the dense medium. Listen carefully again. At the point B, the angle of incidence is more than the critical angle. The process of total internal reflection has taken place at the point B. The light has reflected from the boundary of the dense medium and the rare medium back into the dense medium. So that is how you explain that what has happened at the point B. I have written this answer also. Let me show you my answer. Angle of incidence at the point B is more than critical angle of prism, so total internal reflection took place. Muskan, do you understand?
Yes, sir.
Have you written this thing in your booklet?
I'm writing, sir.
Okay. Angle of incidence at the point B is more than the critical angle of prism, so the total internal reflection took place. Very simple. Let's check the marking scheme also. The marking scheme for the third part says the angle of incidence incident angle is greater than the critical angle, 1 mark is for this, and the total internal reflection occurs, 1 mark for this. So,
Done, sir.
okay. So hopefully is clear to you. Figure 10.2 shows a second horizontal ray of blue light. Figure 10.2 shows a second horizontal ray of blue light striking the prism at the point C. On the figure 10.2, continue the path of the second ray through and out of the glass prism. It's a 2 mark question, and you should have your, if you have your, geometry box with you. I've done this. I've done this answer. Okay, let me show you. I okay. So on your screen, you can see that the second blue ray which entered at point C, it will be bended away from the normal. Sorry, it will be bended towards the normal. So because this upper ray is also blue, so this is also blue, so they will have the same deflection. So this blue line I will draw parallel to the AB line. The line, this blue line should be parallel to the AB line. That's very important. Both of them, they are blue in color. So they will have the same angle of deviation. They will be bended the same angle, through the same angle, sorry. So when this blue ray will strike here, I will draw a normal here. Here, this angle of incidence is quite large. So most probably it will be more than the critical angle. So I will check the angle of incidence. I will draw same angle of reflection on this side, and I will draw a reflected ray here. So you see here, the total internal reflection has taken place. And by taking the angle of incidence and angle of reflection equal, I will draw this ray according to this angle. This angle of reflection should be equal to the angle of incidence here. And I will draw this, and when it will enter here, I will draw normal here. And you can see this angle of incidence is smaller. So the light will enter into the air and it will bend away from the normal. Little tricky question, but I hope you can draw this in your booklet. If you are done, to kindly let me know.
Okay, sir.
You have to draw these blue lines. Muskan, when you are done, kindly let me know.
Done, sir.
You are done. Very good. Very good. Okay, so let's move to the next part. And he says the question number, this is question number 10 and its B part. Uh, um, a lens is shown, a camera lens. The camera lens shown in the figure 10.3 is used to photograph the object O. The object O is 2 centimeter high and is placed at 8 centimeter from the center of the lens. The lens has a focal length of 3 centimeter. Draw rays on the figure 10.3 to find the position and height of the image formed by the lens. Label the image I. It's a 3-mark question. Draw rays on the figure 10.3 to find the position and height of the image formed by the lens. Label the image I. I've done this. It's a 3 mark question. The focal length is, remember this thing, the focal length is 3 centimeter. Let me show you my work. I have done this. So here we go. Let me increase the size so you can see it. So on your screen, this is showing the, you see, first of all, I have drawn this green line. This green line is basically representing the principal axis. So one of my students is saying, please let me join in. I think we have not joined in. What's the problem? You are already, Zainab, you are already in. Why are you saying let me join in? You are in. Okay. So let me. Okay. First of all, draw this green line. I have drawn this green line. This means the principal axis. Okay. One very important thing that he said, the focal length is 3 centimeters. By counting. Okay. By counting. This is the optical center of the lens. This where the cursor is the optical center of the lens. From here, count 15 small squares to the right and put a dot there and call it F. From the optical center, count 15 small squares on the principal axis to the right and mark there F, because 5 small squares are representing 1 centimeter. So the focal length is 3 centimeters. So from the center, the optical center is here in the middle of the body of the lens. From here, count 15 small squares to the right and then put a dot there on the principal axis and write F like I have done. Are you done with this thing?
Yes, sir.
Okay. Then from the head of the object, from the head of the object, start a ray which is parallel to the principal axis and it comes in the lens. From the head of the object, start a ray like the top red one ray which I have drawn. It goes parallel to the principal axis and comes in the lens. And after passing through the lens, it goes through the F and you continue it. Muskan, do you understand what I am saying?
Yes, sir.
Okay, draw it. Start from the head of the object, draw a line parallel to the principal axis. When it passes through the lens, then it should pass through the F on the other side. F is 3 centimeter away from the optical center. F is the focal point, principal focus.
Done, sir.
Okay. That will also start from the head of the object and center of the lens. So it will go undeviated. Draw this second ray, the red color second ray. Draw this ray, beta. Once you are done, kindly let me know.
Sir, I can't hear you.
Are you done? What?
I'm done with B part, first part.
Okay. So wherever these two rays intersected, you can see they intersected here. Join this with the principal axis, like this black line I have joined. This will be your image. Draw an arrow here, and with it write I. I stands for the image.
Done, sir.
Okay. Then he says draw rays on the figure 10.3 to find the position and height of the image found by the lens. Label the image I. 3 marks for this. The next question is determine the height of the image. If you want to find out what is the height of the image, just count these small squares. 1, 2, 3, 4, 5, maybe 5. 5 means 1 centimeter. 5 small squares means 1 centimeter. So it's 1 centimeter or it is 1.2 centimeter. You can also count from your booklet. Because you have also drawn, you can count from there. 5 small squares mean 1 centimeter. So if there are 6 small squares, it means 1.2 centimeters. So you just count your. Can you count? Okay,
Yes,
anyway, we
sir.
are moving according to the diagram which I have drawn. It is 5 small squares. So it's like 1 centimeter or it might be 1.2 centimeter. Okay.
Yes, sir.
Okay. So he says the next question is the image formed by the lens is the real image. Explain the difference between a real image and a virtual image. Explain the difference between a real image and a virtual image. Very simple thing. So this is question number 9 and B third. Okay. So let me show you my work. Let me show you. I have, okay, here I have to write B. Now this is the question which they are asking you. Real image can be captured on screen. Virtual image cannot be captured on the screen. He says, what is the difference between the real image and the virtual image? The real image can be captured on the screen. Virtual image cannot be captured on the screen. It's a 1 mark question. Let me check the marks. Yeah, 1 mark. Let's check the marking scheme also. The real image can be found on the screen, the virtual image not found on the screen. Or you can say rays converging on the real image, rays do not converge on virtual image. Rays only appear or seem to come from a point on the virtual image. So you can write your answer. This is my answer. I have shown you the marking scheme as well. So kindly write your answer and then we move to the next part. It's a 1 mark question only. Okay. The next question is explain how a converging lens is used to produce and view a virtual image. You see, if you want to have a virtual image by the converging lens, the process is very simple. You place the object between the focal length and the optical center of a converging lens. So you see what we will use a converging lens and I will place the object within the focal length of that lens. So when you place the object within the focal length of a converging lens, the converging lens will form its virtual image. That image will be virtual, that image will be magnified, and we call this situation magnifying glass. So it's a 2 mark question. He says explain how a converging lens is used to produce and view a virtual image. Let me show you the answer which I have written. So you see, here we go. This is the answer which I wrote. Place the object between focal point and optical center of a converging lens. Look through the lens from the opposite side of lens where object is placed. Image and object will be on the same side of the lens. You see, this is how a virtual image is formed in a converging lens. What you do, you put the object within the focal length of the converging lens, and when you will look through the lens from the opposite side of the lens, the image and the object, they both will appear on the same side, and the image will be virtual, it will be magnified, it will be erect. Let's check the marking scheme. What the marking scheme says. Marking scheme says place the object within the focal length between lens and the focal point or principal focus. View from the other side of the lens, look through the lens, image same side as behind the object. The image will be behind the object. That's the virtual, magnified, and erect image will be formed. Let me show you my answer again so you can write them also. So here on your screen, my answer is showing. So just don't copy these answers, okay? I show you the marking scheme. This is my answer. Probably you can write better answers than this because this is just to help you. Don't just copy them and write them directly. Are you done?
Yes, sir.
Okay. So we are moving to the next part. And the next part says that's question number 11. Okay, so we are done with the question number 10. Now we are starting question number 11. Let me reduce the size so you can see the whole thing. Figure 11.1 shows parts of a smoke detector. Um, you see, it's a smoke detector. You know, smoke detector we put in the ceilings of the kitchens. So if smoke starts, the alarm will go on and it will start alarm. So the smoke alarms, very simple. They have a positive plate, they have a negative plate, and they have a source which emits alpha particles. So alpha particles are coming here, but when there will be smoke, and the smoke will be ionized, and then the path of the electricity will be completed, and this alarm will be set off, and it will start the alarm. So you don't have to go into this detail. The question is very simple. Alpha particles from the radioactive source ionize the air between the metal plates. There is then a small current in the resistor. When smoke enters the detector, the current changes and the alarm sounds. So the current, when it will change here, then the alarm will sound. Explain why a source emitting gamma rays is unsuitable for use in the smoke detector. The question is very simple. He says, in this, we are using a source which is giving out alpha particles. Why we are not using a source which emits gamma rays? Try to understand. Very easy thing. You see the smoke detector we attach with the ceiling of our rooms. Smoke detectors we attach with the ceiling of the kitchen. So if you use gamma rays, the penetration power of the gamma rays is very high. So from the ceiling, the gamma rays will reach the people which are walking in that room. The people who are inside that room, the gamma rays will be, because their penetration power is higher, they can travel in the air. They will reach the people who are in that room, and those people will be harmed by the radiation. When we use the alpha particles here, the alpha particles, their penetration power is very low. They can only travel 3 to 4 to 5 centimeter in air. So if a smoke detector is attached in the ceiling, the alpha particles will not be able to reach. They will not be able to reach the people in the room. So gamma rays are unsuitable. It's a one mark question, very simple. Gamma rays are unsuitable for the smoke detector because their penetration power is very high, and they will reach the people who are in that room and they will harm them. I've written this answer also. Let me show you my answer. Here's the answer. Okay, here we go. Gamma rays penetration power is very large. They will reach people in the room. and that will cause harm.
Done, sir.
Gamma ray penetration power is very large, and they will reach the people in the room. The gamma rays will reach to the people in the room, and that they will cause them a lot of damage. Let me show you the marking scheme. Gamma produces little or no ionization. This is another factor, that the gamma's ionizing power is low. Passes out of detector, the gamma rays will come out of the detector and requires shielding, reach people. So gamma rays will reach people. These are different type of answer. You only have to write one. Okay, next part. There is an electric field between the metal plates. On the figure 11.1, draw the electric field between the plates. 3-mark question. You see, on the figure 11.1, draw the electric field between the plates. It's a 3-mark question. I've done this. Let me show you my work. This is what you have to do. He says, draw the electric field. So you can see the electric field between the plates will be parallel lines, and the direction of the electric field is always from the positive to the negative. So draw these equally spaced parallel lines and put the arrows in the downward direction. So these red lines are basically representing the direction of the electric field. Equally spaced lines. And on the ends of these parallel plates, the electric field lines will bend a curve outward, little curve. They will be no more straight at the ends of the plates. So beta, kindly draw these lines in your booklet. These red lines are basically representing the direction and the electric field line. Quick, be quick.
Done, sir.
Okay. The next part he asked you is, he said, it's a 2-mark question. The second part, explain why the alpha particles in the figure 11.1 are deflected slightly as they pass through the electric field. Explain why the alpha particles are deflected and state the direction of the deflection. You see, I have shown you here the alpha particles, because the alpha particles are positively charged. Alpha particles are positively charged. So they will be repelled by this positive plate and they will be attracted to this negative plate. So in this, when the alpha particles will pass through the electric field, they will be deflected towards the negative plate. They will be deflected towards the bottom of the page. And why? Because they are positively charged. Alpha particles are positively charged. They are repelled by the positive plate. They are attracted by the negative plate. So let me show you my answer. I have also written this answer. Alpha particles are positively charged. They will be repelled by the positive plate and attracted to negative plate. So they will be deflected towards the bottom of the page. Kindly write this answer. It's a 2-mark question.
Done, sir.
Okay. So you see, let's check the marking scheme. The marking scheme says alpha charged positively, alpha repelled by positive, attracted by the negative. 1 mark is for this thing. Deflected down towards the positive. Down. Deflected down, okay? Towards the positive plate. I don't know why he's writing towards the positive plate. There, they should have written towards the negative plate. Okay?
Yes, sir.
Let's move to the next part. State and explain how the path of gamma rays differ from the path of the alpha particles as they pass through an electric field. You know, the gamma rays, they are neutral. The gamma rays, they have no charge on them. So when the gamma rays will pass through, these plates, when the gamma rays will pass through this positive and negative plate, because the gamma rays gamma rays have no charge on them. The gamma rays are neutral. So when they will be passing through them, through these plates, they will go undeflected. There will be no effect of this electric field on the gamma rays. They will go straight, no deflection, because the gamma rays are neutral. They don't have a charge on them. It's a 2-mark question. So I've written this answer also. Let me show you my answer. On your screen, this answer is showing. It says the gamma rays are neutral. So in an electric field, they will go undeflected. Are you done?
Yes, sir.
Okay. So the gamma
Yes, sir.
undeviated straight line, gamma uncharged. These are for 2 marks. Okay. One is for telling that the gamma will go undeflected, undeviated, undeflected. And the second mark is for saying that the gamma is neutral. It has no charge on it. It was a 2-mark question. Very simple. The D part, the source used in the radioactive isotope americium-241, which has a half-life of 500 years. A sample of americium-241 is left for 1500 years. Determine the fraction of the original number of atoms of americium-241 left in the sample after this time. So you'll see your half-life is 500 years and the time passed is 1500 years. So divide 1500 with 500. So you will know that there are 3 half-lives passed. Total time passed is 1500 years. One half-life is 500 years. So divide 1500 years with 500 and you will get 3. It means that the time, how many half-lives have passed? 3 half-lives. I've done this on a grid. Let me show you my work so that. So let's suppose that at the start the number of the atoms was n naught. When one half life has passed, this will become half n naught by 2. When another second half life will pass, it will further become half. So it will become n naught divided by 4. When the third half life has passed, it will further become half. So it will become n naught by 8. So what is the fraction? The fraction is 1 by 8th of the original atoms are left. 1 by 8th of the original atoms or sample is left. Do you understand this? Hello?
Yes, sir.
Yes, sir.
Okay. So that's it. We'll move to the next part. Let me check the marking scheme also. So marking scheme says that 1 by 8th will be good. Okay, so we are done. There will be 3 half-lives. Okay, let's go to the next part. Another isotope of the, he says another isotope of the same element, americium-242, has a half-life of 16 hours. 16 hours only. Explain why the half-life of americium-242 makes this isotope unsuitable for use in a smoke detector. You see, if you put this in your smoke detector, its half-life is only 16 hours. So after maybe 3, 4, 5 days, you have to replace that sample, because if its half-life is only 16 hours, so after 3, 4, 5 days, after 5 days, suppose, all the americium would have decayed. And then you will have to buy new americium and put into the smoke detector. So this is not suitable. Its half-life is too short. And we have to, after every 1 week, we have to buy a new americium to put into the smoke detector. Let me show you my answer. I have written this answer also. All of the sample will decay in few days and smoke detector will need to be equipped with a new sample of the radioactive sample or radioactive isotope, you can say. So because its half-life is very short, if you use this, in few days it will be gone. It will decay. So you will have to buy a new sample of the radioactive isotope and put into the smoke detector. Do you understand?
Yes, sir.
Yes,
Okay.
sir.
Okay. Let me check the marking scheme. What the marking scheme says. The marking scheme says the D second part decays too fast. This will decay too fast. Have to replace source often. So you will have to replace it. And current falls too quickly. Detector only work for a short time. So just write what I have written. Okay. Then he says atoms of americium 241 and americium 242 contains protons, neutrons, and electrons. State two similarities in the structure of an atom of americium 241 and an atom of americium 242. You see, they both of them are isotope of each other. So what will be the similarity between them? They will have the same number of protons in their nucleus. They will have the same number of electrons in their orbits. So this is the similarity. So they will have the same proton number. They will have the same proton numbers in their nucleus. And they will have same number of electrons in their orbits. Let me show you my answer. They have the same number of protons. They have the same number of protons in their nucleus. They have same number of electrons in their orbits. That's the similarity between them. Let me check the marking scheme. What the marking scheme? It's a 2-mark question, you see. Any two of number of protons, number of electrons, charge on the nucleus. You understand this?
Yes, sir.
Similarity, yeah. Okay. So next one, he says describe the difference between an atom of americium 241 and an atom of americium
Different
242. Now
number
you
of neutron. Different
sorry?
number of different number of neutron.
Yes, they will have different number of neutrons.
Different number of mass. Yeah.
So their nucleon, one thing is that they will have different number of neutrons, one difference. The other difference is their nucleon numbers will be different. Okay, I've written this answer. Let me show you my answer and they have different number of, let me increase the size so you can see this whole thing. They have different number of neutrons in their nucleus. And the second difference is they have different number of nucleons, or you can say their nucleon number is different from each other. Let's check the marking scheme.
Done, sir.
Number of neutrons, they are different. Nucleon or mass number or mass. Okay, that will be the difference. So by doing this, we have reached the. So my dear students, today we have done May June 2012 Physics 505421 paper. It's a theory paper, and this paper belongs from the Zone 1 Variant 1. And in this video, in this session, in this class, we have only attempted its section B. The section A of this paper we will do in another session, but this session only contains the section B of this paper. I hope that this session has been helpful to you, and if you will be watching this video, this will improve your answering skills of the physics. The best way of using these videos is that you should have a hard copy of this paper, and by watching this video you write your answers in your booklets. If these videos, this session especially, has been helpful to you, don't forget to subscribe to my YouTube channel. And my name is Ferhan Mazher, and I was trying my best to convey you all the concepts. So thank you very much, everybody, and have a good day. God bless you all.